In this section, we are going to study the Lorentz transformations. So we consider two frames, S and S prime frames. S prime frame is moving in the positive x direction with a velocity of u. So at the t equals 0, S frame and S prime frame exactly the same. Then after the t, S prime frame with the distance of the ut in the positive x directions. Then we'd like to find out the relation between the x coordinate in the S frames in the x prime coordinate in the S prime frames. X coordinate, you can measure the distance S. So S frame can be expressed the sum of the two lengths ut plus this length. But this length is measured by the person in the S prime frame is x primes. But in the case of the special relativities, we have to take into account Lorentz contractions. So if this length is measured by persons in the S prime frames, this length is observed by the person in the S frame. You have to multiply these factors, square root 1 minus u over c squares times x primes. So from this equation, x prime is expressed this equation. So by considering the Lorentz contractions, and the y coordinate and z coordinate it doesn't change. So y prime is a y, z prime equals z. Then we'd like to find out the coordinate transformations. So as I explained, if we consider the S prime is moving with respect to x, we have this equation. X equal ut plus square root 1 minus u over c square x primes. But also we could consider S prime frame doesn't move. So this u is actually S frame is moving to the opposite directions. This is minus u. Then we could write down the S frames using the value of the S prime frames. So this is, we have to use this equation, but we have to change. U is gonna be minus u, and the x is gonna be x prime, and the x prime is gonna be x. Then x becomes x prime, and the u is minus u, and the t is a t prime. So t is going to be t prime. And the square root 1 minus u over c squares. And the x prime is going to be x. So we have a new equations. So by combining these two equations, we could derive this equation. So from these equations, you can substitute this one. So x is equal, so we start with x prime equal minus ut prime plus square root 1 minus u over c squares x. So x prime is equal x minus ut over square root 1 minus u over c squared. So from these equations, you can express x minus ut equals square root 1 minus u over c squared minus ut prime plus square root 1 minus u over c squared x. Then you can expand. This is minus square root 1 minus u over c squares ut prime plus 1 minus u over c square x. This is x minus ut. So x is going to be cancelled out. Remove these equations. Square root 1 minus u over c square ut prime equal ut minus u square over c square x. And then u, 1 over the u is going to be cancelled. So t prime, you can discover t prime. T minus ux over c square over square root 1 minus u over c square. So we have this equation. Proved this equation. So by combining transformation for x and t, we have these 4 equations. Relation between the x, y, z, t to the x prime, y prime, z prime, t prime. So transformation t, x, y, z to the t prime, x prime, y prime, z prime. So often we use instead of t, we multiply c. So ct x, y, z to the ct prime, x prime, y prime, z prime. So we call this transformation in the 4D space. These are Lorentz transformations. In the case of the really slow motion of the particles, in this situation, 1 minus u over c squares is nearly equal to the 1. So x coordinate is x prime equal x minus ut, t prime equal t. So this is the Galilean coordinate transformations. In the limit of the low velocities, we can safely use the Galilean coordinate transformations. So in the case of the also velocity should be transformed. So we use the 2 equations. X prime is x minus ut over square root 1 minus u over c squares. So we'd like to small change of the coordinate. So variable is x and t or x prime. So you just substitute d. So it's here dt. Then you will get this equation. dx prime is a dx minus u dt. Also dt prime, you put the d signs, changing here. So next equation you will get. Velocity is defined in the change of the distance per unit time. So but time have to be measured in each frames. So v sub x prime, this means distance have to be measured in the s prime frames, so dx prime. And also time have to be measured in the s prime frames, so you have to put the dt primes. So you can substitute these 2 equations here. Then divided by dt, you will get the next lines. Then dx dt, distance is measured in the s frames, and also the time is measured in the s frames. This is the velocity in the s frames. So it's going to be v sub x. 1 minus u over c square v sub x. So very complicated formulas for the relative velocities in the special relativities. But this is actually exact equations for the relative velocities. In the limit of the low velocities, u over c is really small, so this is going to become 0. So it becomes u sub x prime equal u sub x minus u. So we often use this is a definition of the relative velocities. But this equation is the true in only case of the low velocities. In our daily life, most of the cases, the speed of the particles is much slower than the speed of the light. We can safely use this equation. This equation exactly same as the Galilean coordinate transformations. Okay, this is the end of this session.